Hello, everyone. Welcome to the Azure channel. We are going to talk about Azure Container Apps microservice development with Keda and Dapr. And I have here with me today Nilesh GULE from Singapore, Microsoft MVP, a very popular MVP, I would say. Nice YouTube channel that we're going to share soon here. Welcome, Nilesh.
Thanks, George. Nice to see you.
That's great. That's great. I was just going through your slides and I have amazing content to show. And yeah, be free. Let's go straight to that. If you want to share your screen.
Okay, let me know if you are able to see it.
Yeah, I can see it. That's nice. You
Okay.
can present yourself, please.
Yeah,
And yeah,
thanks.
let's go for it.
Okay, so as George said, my name is Nilesh Kule. I'm a Microsoft MVP since 2018. So I just received the 5 years special card or the special disc that we get from Microsoft for completing 5 years of community service as part of MVP. Along with that, I also blog on my website, which is Hands On Architect. You can find me on all other social media using my first name and last name, which is Nilesh Kule. Uh, I'm available on GitHub, Twitter, LinkedIn, YouTube, everywhere using this. The combination is quite unique and it's quite easy for me to find social media handles using this name. Apart from being in the technology where I talk about technology a lot, I like to evangelize technology. I also like the game of cricket, and it's not surprise that like many other Indians, I also follow the game of cricket very closely. If you'd like to discuss about cricket with me outside, I'm very happy to talk about it. I'm quite passionate and I follow the game very religiously. I'm also a co-organizer of Azure Singapore User Group, the meetup, and we regularly host events and conduct different technical sessions. So if you are interested, you can again visit our YouTube channel where you can find recordings of all our previous sessions that we have done over last 3 4 years, especially during the COVID time. A bit of background about myself. I was born in this very little small place in India called Goa, which was a Portuguese colony, and it was ruled by Portuguese even after India was liberated from the British rule. So Goa was under Portuguese rule until 1961, and you can see some nice pictures of historic monuments from Goa, churches, temples, beaches. It's quite popular among the Indian crowd as well as the foreign tourists for its very beautiful beaches. So if you happen to be in India sometime, do visit this place. And you will find that it has a distinct architecture style of the buildings and the food. The culture is quite different from rest of India. Now coming back to today's session or this video.
Nilesh, but it's on my wish list to go there. And I know
Nice to
that they
know.
love soccer. They love football, soccer. I'm from
Yes.
Brazil, and it's on my wish list.
Nice to know. So hope you have a time to go there and you enjoy the place. And I would love to hear from you. How did you find the place once you go and visit?
Nice.
So coming back in this session, we are going to talk about the Azure Container Apps, which is the one of the upcoming service and the latest service added to the Azure services. In the app demo, we will also see a distributed app runtime or Dapr integration with Azure Container Apps, and also a auto scaling feature, which is again natively supported by the container apps using open source project called as Keda or Kubernetes driven event driven auto scaling. So we'll look at these two different integrations, and for that we will build and deploy a small demo application called as Tech Talks, and I'll also provide some references, and we will have some Q&A along the way. So to understand the need for this application or the prerequisite is that I expect people to have a basic understanding of what are the cloud native applications, like the distributed nature of cloud native applications, the highly scalable, resilient, fault tolerant, observable, all these things which are like key characteristics of cloud native applications, along with automation, where we talk about things like DevOps, GitOps, infrastructure as code, CI/CD, A bit of understanding of these concepts is required. You don't have to be an expert in all of this, but because we are going to talk about these topics in different sections of the demo, it's good to understand about cloud native applications, how they are built, how Docker comes into the picture and helps us to make these applications self-contained, how we can use container registries to publish our own custom application images using Docker, like a Docker registry, or it could be public registry like a Docker Hub, or it could be private registry like Azure Container Registry. So for this demo, I will be using a private container registry, which will be hosted on Azure, the Azure Container Registry, or ACR. And then a bit of Kubernetes knowledge, which is about orchestrating the containers and different features like self-healing, service discovery, scaling, which are very much part of Kubernetes. A bit of understanding of this is helpful in understanding what I'm going to demo. So instead of spending too much time on talking theory, let's look at what the demo is, and then we can spend some time understanding how did we use different features of Azure Container Apps. So for the demo, I'm going to use a small application which I built. It is called Tech Talks. So think of this like a event management or Tech Talks management kind of an application where we have I don't have a screen or user interface. So we are going to simulate it in way. So there is an API, web API, a .NET Core API, which is used to produce Tech Talks or to register Tech Talks. And then there is a consumer which consumes those Tech Talks. So this consumer is going to pick the message which is stored as a Tech Talk is stored as a message in RabbitMQ. So we decouple the producer and consumer by using a pub/sub mechanism, which is shown here. We are going to use RabbitMQ for that. And then we are going to use another component or an open source project called as Dapr. Dapr is a distributed runtime which helps us to build microservices, and it provides various services like service-to-service communication, secret management, then the pub/sub mechanism. All these kind of services which are cross-cutting concerns, they are provided or they are encapsulated as part of Dapr. So we will use Dapr between our Tech Talk producer and consumer and to communicate with the RabbitMQ. And as I said earlier, the container images will be stored in a container registry. And the container registry is in a different resource group, whereas all the other components of the application, the Tech Talks producer, the consumer, and the RabbitMQ, they are part of another resource group. And all this is stored or deployed inside. The producer and consumer are deployed inside what we call as an isolated environment in the container apps. It's called ACI dev environment. And here is a quick overview of Dapr components. What Dapr provides is different types of state stores. So it currently supports AWS DynamoDB, Cosmos DB, Firebase, Redis, Cassandra. So NoSQL databases and even the relational databases are supported here. There is pub/sub components where it has support for Redis, RabbitMQ. There are binding triggers, there are secrets, observability related things like Prometheus. So out of this, we're going to use two. One is the secret store, where it is going to store the secrets, and the other one is the pub/sub component, RabbitMQ. And then there is the Keda. But before we move on to Keda, let me switch to the demo and show how we are going to use this. So in the demo, I have the producer and consumer. So let me quickly show you the code of producer and consumer, what we are doing. Let's start with the producer. So here is the quick API definition for the producer. It uses the pub/sub name and the topic name as the configuration. So currently these are stored or hard-coded in this demo, but we can take this as config parameters. This is named as RabbitMQ pub/sub, and this component name is what we store as a configuration for Dapr. So I'll show you the Dapr configuration also a little later. And the topic that we are going to refer to is named as Tech Talks. So I'm going to produce messages and I'm going to publish those messages onto this Tech Talks topic. Now, when I get a message, so my API will send me a list of messages which are of Tech Talks type. And Tech Talk is, again, if we look at the model, it's a very simple object, and it stores information about what is the ID of the talk, what is the name, what is the category, what is the level. So we have different categories and the levels. And if we go back to the controller, we can see how these are used. So let me quickly scroll through this. Here, the API controller, it has a method called generate tech talks, which takes the number of messages which we will use to generate the workload here, or the certain number of messages. And then it uses a component called faker. Faker is used to create something like, instead of using lorem ipsum, it will give real names, and the kind of objects which will be created will have meaningful names. So we have things like the categories like meetup, it's a free conference, paid conference, hackathon. And same way, the description is like it's a free, paid, or hackathon. And the levels are beginner, intermediate. So typically what you will find in a conference talk, we are trying to model that here. And then the faker is going to create those many number of messages for us. So we randomly give the ID between 1 to 1000, and whatever is the number of messages we asked for, those many number of messages will be created, and they will be passed to our uh, infrastructure code, which will generate those many messages, and it will push it to the RabbitMQ. Let's look at the consumer side of things. How does the consumer process this? So consumer is again API, very simple API, which looks at the topic called the same RabbitMQ PubSub that we saw in the publisher as well. And the topic name is Tech Talks. And we are going to simulate that there is a slight workload here, or a simulation time of 1/4 of a second. So in 1 second, 4 messages are going to be consumed. And we are also going to consume a batch of messages, which we configure separately outside of the application. And to simulate that it's doing some work, we just log the details of the tech talk. Now, where does this topic and the PubSub and the tech talks link comes into the picture? That we do using Dapr. Now, the way Dapr works is it has these different components, and in my configuration, I am creating a YAML file to specify what is my type of component for Dapr. So I'm creating a new component type of PubSub, and within PubSub, if we go back to the slides, we saw that Dapr supports different types of PubSubs. We are going to use the RabbitMQ. So that is why we say we are using pubsub.rabbitmq, and then we provide the metadata based on the type of the PubSub service that we are using. So the metadata here for RabbitMQ is the host. Is it a durable queue? What should happen when it is unused? Do we want to automatically acknowledge? And various other things related to the metadata for that RabbitMQ, the host, the server, as well as the queue. And this is where I was saying that we are going to fetch a batch of messages. I can configure a prefetch count. So instead of taking all the messages which are there in the queue, I want to create a way in which only a part of the messages or subset of the messages are collected. So I'm going to fetch 50 messages. That is the configuration. And based on this configuration, I can then switch if required. So let's say tomorrow I want to deploy this application to a different environment where RabbitMQ is not available. And let's say in our organization, we are deploying it to Azure, and Azure Service Bus is available. I can easily create another configuration for Azure Service Bus and replace the metadata. Instead of RabbitMQ, I provide the metadata for the Azure Service Bus, and without making any change to my application code, I would still be able to use the same publisher and consumer. I don't have to rely on the SDK of RabbitMQ or the SDK of Azure Service Bus. Dapr will do that work of binding my topic and my code to that particular topic. That is the ease with which we can work with Dapr. It requires only the configuration to configure those different components. Now with that, let's go and generate some workload and see this in action. So before I generate the workload, let's quickly see the RabbitMQ UI here. This is the management UI for RabbitMQ, where we can see what are the queues that we have and what are the exchanges. So the topic that we mentioned in our configuration, it gets mapped to a queue in RabbitMQ. And the
Can
name
you
of the
zoom
queue
a little bit, Nilesh? Just a little bit. Zooming.
is this better?
Yes, better now. Yep, looks good.
Okay. So we have a queue named as RabbitMQ Consumer Tech Talks. This again is based on the convention which Dapr follows. So Dapr has its own convention of creating the queue or looking at the queue. And based on that, I have created this queue. And right now we can see that there are no messages in this queue. And there is one consumer which is deployed and which is looking at this particular queue. So let's go and generate certain number of messages. So I have this extension in Visual Studio Code, which again gives us the ability to send request. I'll show you how we get this URL, and I'll also walk you through the deployment step. But before that, let me just start this request. And let's say instead of 5,000, we are going to generate 10,000 messages. And when I hit send, it's sending the message or it's generating the workload, and we should see the output here once the messages are generated. So we get a response as 200 OK, which means the API call was successful, and we should be able to see some messages. So we can see the message count is increasing, and we have untracked 50 messages because of that prefetch size of 50. The one consumer has gone and picked up 50 messages, and it's processing those. Now, to deploy this, I again have a script. So let's walk through that script and see how did I deploy this application. I have this script which is used to set up the whole environment for me, Azure Container Apps environment. I have some of these parameters passed to the PowerShell script, like what is the subscription I want to use, what is the resource group name I want to use, where is the location of the resource group where I want to create all these resources, and the environment name. Environment is a concept in Azure Container Apps which allows us to isolate a group of applications. So think of it like we have a dev environment, or we have a SIT environment, we have a pre-production environment. We can create an environment which isolates it from other environments, and we can deploy a set of Azure Container applications within this environment. So the script is idempotent. Even if we run it 3 or 4 times, it will check if the resource exists, and it will create the resource only if it doesn't exist. So we start with creating the resource group. Once the resource group is created, we go and create the container instance or container app, the instance of a Azure Container App. Once we have created the app, we create an environment. And once the environment is ready, we are ready to deploy different applications in that. So the first thing we do is we create the Dapr component. So the configuration that I showed you earlier for Dapr, the PubSub, RabbitMQ PubSub, we take that YAML file and we create a component, a PubSub component called as RabbitMQ PubSub. Now we have to be very careful with the naming. This is exactly the same name that our application will use. So if you see here, I'm giving the name, component name as RabbitMQ PubSub, and my producer and consumer is going to use that same name for the PubSub. If there is any typo, we will not be able to connect our producer and consumer. So be very careful about the naming and the component names that we use. So once we have the component deployed, then we go and create our producer, or we deploy the producer application. This uses the Azure CLI command for creating the producer application with the name as TechTalks producer. We are specifying what is the image registry from where we want to pull our container image. So this is the private registry that I was referring to earlier, and it has a repository called as TechTalks Producer, and there is a tag for my application, which is Azure Container Apps. So I'm going to use this particular version or tag of the image, and I'm going to deploy that. I also want to expose this on port 80, and I want to have a ingress. So ingress is a way in which external applications or we can access the application from outside of our Azure environment. If I don't give ingress as external, the application will be available only within Azure. We will not be able to access it from outside. So since I want the API to be accessible from outside of the Azure, I'm deploying this with the external ingress. This will give me a public IP and a fully qualified name. And then I'm also saying enable Dapr for this. So when I say enable Dapr, it gives that Dapr integration for my application. And I can use all those services that Dapr provides as part of this application. And then I provide some metadata like what is the Dapr ID for my application. It is named as RabbitMQ producer. What is the Dapr port? I can also specify the number of replicas. Azure Container Apps is a serverless offering, which means that we don't have to manage the underlying infrastructure, and we can scale the resources as and when needed. So for my producer, I'm saying I need minimum 1 replica and maximum based on the load, scale it up to 3. Same way, I go and create the
And
consumer.
Nilesh,
Yes.
there's just one nice thing there. Even when you have one replica, if you're not receiving calls for that, you just pay like a standby fee. You don't pay the full amount. That's
Yes.
a nice thing on container apps that you don't have
Yes.
on other service.
That's a
And
very
even
good
you can,
point, George.
yeah,
Yeah. And in fact, we can scale to 0 as well. If I don't want even 1 replica, if the workload is, let's say, very unpredictable, and I don't know exactly at what point in time my API is going to be consumed, I can even say scale it down all the way to 0. But there will be a slight warm up time when the new request come in and the first replica has to be created later on.
yep.
Yeah. And then same way, we create the consumer as well, where we check if the consumer exists. If it doesn't exist, in the same environment, in the same resource group, we create a consumer with the name as TechTalks consumer. Uh, the image container registry is same. Just the name of the image is different or repository is different. This time we are using TechTalks consumer, and the tag is same for producer and consumer, which is Azure Container App. Now in the target port, again, we are targeting 80, and the ingress, this time I don't want to expose my consumer to the outside world. For me, it just needs to consume and process the messages internally. So for that reason, I create the ingress as internal. And then again, I enable the Dapr and I provide other metadata related to the Dapr. And in this case, you can see that I'm starting with minimum 1 replica. I'm not giving the max or what is the upper limit for my scaling. In this case, it will use the default setting. And if the workload increases, it will automatically scale my uh, container instances or consumer instances in this case. So with this, I've gone and deployed the application, and that's what we also saw in the UI here, that it is running, one consumer is running, it is consuming 50 messages. How can we verify this? So if we go in the portal, and if you look at the resource group, let's start from the topmost layer where I have this Azure Container App resource group. Within the resource group, we can see that there are various resources which are created. There is this the dev environment or container apps environment which is created. Then there are the VNets, the virtual network for networking purpose. We can skip the RabbitMQ part because RabbitMQ is a marketplace image which I've used from Bitnami. That is not part of the container apps itself, but I've provisioned it separately. And then we have these two applications or the container apps, the producer and consumer. And we also have a log analytics workspace for the environment created. So let's go into the Tech Talks producer and look at some of the details of that. So I can create all this using the portal as well. What I showed was using the Azure CLI commands via PowerShell script. I can use the portal also to create a new instance of the environment. I can create a new instance. So let me just quickly go back here. Let's say in the same uh, resource group, I want to create a new instance or new environment. So I can click on new here and I can say Azure Container App. And if I click on this, it will give me the option to create a new environment. Then it will create new instance of that. So that is how we can use the portal as well to create these things visually if you don't want to use the scripted approach. So let's go into the producer and look at some of the details of the Tech Talks producer. We can see that it's in East Asia, the resource group is same. And this is the URL I was saying that it will create a fully qualified FQDN will be provided to us if we ask for a external one. For the internal one also, we will have internal FQDN, but it won't be accessible from outside of Microsoft Azure. So I can copy this to a clipboard and I can use it for uh, making the request. So I can use Postman or any other tool to make test against this particular URL. And that is what I have done here in this, the demo HTTP extension, which I'm using for the Visual Studio Code. We are using that same URL and we are calling the generate number of messages, generate method with number of messages as 10,000. And then we also get various other things like monitoring. There are things like revisions. We can create multiple versions of the same application and we can maintain multiple revisions. We can also set up a CI/CD pipeline using GitHub Actions. We can do a integration with GitHub Actions using this. We can also create secrets. So we will look at the secrets part because we are using secret, or we will be using secrets a little later. And similarly, for the consumer, we have the consumer details. So you can see here that since we said we don't want to expose it outside, the ingress was specified as internal. That is why in the FQDN which is created, we have .internal in the name of the URL. And how can we verify that this is running? On the left-hand side of the pane, you can see various other things related to authentication, secrets, ingress, CI/CD pipeline. What I want to show is how we can see the logs related to the consumer. If you remember from the code, every time we pull a message, we log it. So we can see here in real time that this particular consumer which is running is writing that information about which message or which tech talks it has processed. And every second there are 4 messages which are consumed or 4 tech talks. If we stop this and we look at the details, we will find 4 entries for every second in this log. And we can also switch between the containers. So when we say enable Dapr, we find that there is also a sidecar container created along with our application container. And this is the sidecar container or a type of container. If you know how sidecar works, it works side by side to your application container and it provides cross-cutting concerns. So Dapr is deployed as a sidecar container when we say enable Dapr. And we can also look at some of the logs, what Dapr is writing. So this is how we can debug the application if there is any problem. This is one of the way in which I check if the application is working and everything is fine with the application. So let's switch back to the slides for a while. So what we saw here was how we configure the PubSub component, the RabbitMQ, and how we use that in the application. The next thing I want to show is how we can scale. Yeah.
Just a comment there. If you go back one slide,
Yes.
if you're watching like a nice improvement on your demo there, if you want to do a pull request for Nilesh, was to put like app insights observability on this demo. You could send
Yes.
all these logs that you were showing there to App Insights, and then you could debug from App Insights. Maybe it's a segue for this presentation. Nice one.
Yes, that's a good point. In fact, I am open for people raising pull request on this particular repository. I don't have all the time in the world to do all the modifications that I want. So if somebody wants to use this as a base for their learning, they can as well integrate various other things like the Key Vault. If you want Kubernetes, Jaeger, for example, it all can be done. And I'm more than happy to accept pull request for this application.
That's great. Yeah, observable App Insights could be a nice one there.
Yes, that's a very valid point you're making, George. Okay, so let's look at scale. Why do we need scaling? Now, if we go back to our RabbitMQ consumer here, we can see that because of one consumer and the pace at which it is consuming those messages, it is quite slow. I've been talking for last maybe 10 minutes in starting this demo, and we can see that there are still like 2000 messages in the queue to be processed. So in such kind of scenarios where we want, let's say, the messages to be processed quickly, and we want to scale the number of uh, consumers, we can use Keda. We can scale our application based on different metrics. Traditionally, applications have been scaled on metrics like CPU usage or RAM usage, but nowadays, cloud native applications, they are not just dependent on resources which are specific to applications like is specific to your infrastructure like the CPU or RAM. You have backing services like messaging, you have databases, you have things which are outside of your own application and the infrastructure where your application is running. So we might need the sort of triggers which are outside or metrics which are outside of the application environment, and that is where Keda comes into the picture. It has a vast array of autoscalers which can run on external metrics. So I put a small screenshot here which talks about 40 or 50 different supporters of the Keda, like the scalars which are available in Keda. These are again related to databases, NoSQL databases. There is messages. There are things like the OpenStack, there is Postgres database, there is Prometheus, Grafana. So things which are related to observability, all these kind of things, we can scale our application based on these factors. It need not be just based on CPU and RAM. And Keda again helps us to scale back to zero. So if we don't need the application instance running, if there is no workload required, it can scale everything back to zero, and then it can scale again when there is a need. So let's see how we can integrate Keda. Keda requires two things. One is the source where it should look for the trigger. So in our case, RabbitMQ is the source of information where Keda should look for when it wants to scale. And the second thing is what it needs to scale. So in our case, it is the consumer which we have to scale. And this needs to scale based on the number of messages which are still pending to be processed. So Keda sits in between our RabbitMQ and the consumer. And looking at these two things, or mainly looking at the number of pending messages, it can decide whether the scaling up has to happen or it has to scale down. So how do we integrate this with the application? For this, we go and create again a configuration for Keda. So I have created again a small script which does this in one single go, but we can do it again using the UI if we prefer. So what's happening here is we take the same parameters again. What is the resource group? Where is the location of the resources we want to deploy? And what is the environment name? And then we create a secret in the container app. So for Tech Talks consumer, we are going to create a secret which is going to point to our RabbitMQ host, and then we deploy that secret. So we create a secret or we set that secret using this AZ container app secret set command. Here I'm showing the secret in plain text. Again, there are ways using Dapr as well as Azure Key Vault where we can manage this in a much better way. But for the demo purpose, I'm showing it in plain text. Please don't do this in your production environment. And if we happen to talk about this same demo maybe 6 months down the line, I'm pretty sure I would have modified this to include a better approach. But for now, let's say this is the secret we want to create. And then we go and update our TechTalks consumer. We say that now our scaling limit has to be between 1 to 25. Minimum replicas should be 1, maximum replicas should be 25. We create a scale rule, which is called as RabbitMQ Keda auto scale. The scale rule type is RabbitMQ, and it uses the secret that we created earlier. So the metadata or the variable name here says rule auth. So it is the host equal to RabbitMQ host, and the scale rule metadata is which is the queue, what is the mode we are going to use to scale. So I'm saying queue length is the parameter I want to look at when I want to make the decision to scale up or down. And the value is 50, which means that as long as there are 50 messages in the queue to be processed, I want to scale up. And let's go and deploy this and see what happens. So currently we have 750 messages to be processed. Maybe by the time I deploy, those messages would be processed. So let's go and generate
Nilesh,
another.
just you before, yeah, put more message there. Just before you do it, just do like a recap. You create the Azure Container Apps environment. You deploy a couple of applications, like a producer and in a consumer. You have the message queue there where you send a message. You're decoupling the producer from the consumer.
Yes.
And now you send a message for this queue. You are simulating message there.
Yes.
Using the API. The API is going to send to the message queue, and the consumer is going to start scaling using this Keda metric that you just created.
Yes.
And every time that there are 50 messages on the queue, they create another instance on Container App. They scale out to process those messages faster than before. I think that's amazing.
Yes.
I think that's what people do in production.
Yes. So that's why you see there is 4 instances I'm showing in this diagram here of the consumer. But in real life, because we gave that scale limit between 1 and 25, it will scale within that range.
And serverless, you just pay for the time that consumed, then doesn't matter. They're going to scale down after that.
Yes. So let me send these messages. So let's say 15,000 messages I'm going to send. And sorry. We should be, yeah. So we see a jump here, which means those messages are getting populated. While the messages are getting populated, let me go and apply that particular auto scale, the Keda configuration. So I have this auto scale consumer script in my demo folder. I will go and run that.
You just pointed to you define the rule now that's going to scale based on the 50 messages on the queue. Every time 50 message, then it's going to create one new instance up to 25. That's exactly what you said.
Yes.
The maximum 25 instance. By the way, you don't have to go all the way to 25. Depends how fast you want to process that.
Yes, that's correct. And what we will see is the scaling doesn't happen at one time. So you see there are already 2 consumers now. And the number of messages, we will see this changing here, untracked as 200 right now because there were 4. It became 5, so 250. But you see that it is not going from 1 to 25 in one stretch. It will say, let's try 2. Then from 2 it will go to 4, 4 to 8, 8 to 16, like that. So it progressively increases the number of consumers.
It depends how
And
fast your consumer startups, if it's a very
yes,
light, .NET Core, it's very fast to boot.
yes, that's also the benefit of containers, right? They are very fast to start up. So we
To
don't
start up.
need like a large amount of time to set the containers up. Unlike VMs or other forms of deployment, containers, they are really lightning fast, in my opinion.
Yeah.
So we can see that the consumers, as number of consumers is growing, and it is going to consume all these messages. If we wait for a while, once all the messages are consumed, there is also a cool down period. It will wait for it to see if all the messages are consumed and if there is any need for all the consumers to be alive. And after a while, we will see the reverse process where it will remove those instances which are not required. So that is again the benefit, biggest benefit of Keda, where without changing the application code, it can scale the consumers in this case, but like the application instances, and the application doesn't have to be even aware that it is being scaled. So no code changes required. Just with introduction of Keda, looking at different parameters, it can scale the application very easily, and it can scale up and it can scale down as well. So we can see that it is not going beyond 11. Although we gave the number of consumers as 25, it somehow stopped. And so, as I was saying, it went to 21. But again, the point that I was trying to make was the scale up happens in progressive manner. Same thing for scale down. It is not going to shut down all the way from, let's say, 25 to 0 or 25 to 1. It will scale down progressively.
Yeah, they just process all the message now. It's all gone.
Yeah.
And it's going
So
to
now
take, I
all the
think, up to
messages are
5 minutes,
gone.
I think, to scale down.
Yes. So I think what we can do is we can switch back to the slides for a while and then come back and see
Yeah.
here. Uh, Before I move to the slides, I can also show the things that I did using the scripts. If we go back in the UI, we can do the same things from the UI as well. So the secrets that I was talking about, or the Dapr, say for example, I want to configure Dapr using the UI. I can come here, I can enable the Dapr using the portal, and then I can provide all these parameters. uh, if I want a custom component, again, I can create a component for Dapr in this. Same way for the secret. If I go to the secrets section, we will see that there is a RabbitMQ host secret created. And if I click on that, we will see the value, or it's redacted here. But that is how we can also do these things using portal. We don't have to use the script every time. Even the scaling can be done from here. So if you want to define the scale, what I configured using Keda, that can also be configured using UI. And how do I know what are the things that I need to configure? So let's say the RabbitMQ, for example, I can go to Dapr docs and find out I'm not specifying all the parameters that are supported. I chose only the ones which were relevant for my demo, but the RabbitMQ component as such, the PubSub component supports various other parameters. And you can find this in the Dapr docs. You can go to each of these different supported components, and you can find out what is the parameters or metadata which is required to configure that particular Dapr component. Same way for the Keda, when it comes to the Keda scalars, each scalar has a different configuration. So as of this session, there are 56 auto scalars, and we can look at RabbitMQ, which I'm using. So we can find out again what values need to be specified for Keda to work effectively. So with that, let's switch back to the slides. So we saw some of these things during the demo, and I thought we will quickly highlight the benefits of using cloud native applications and building applications using the microservices kind of architecture. It helps us to reduce the time to market. It helps in the ease of management. So we saw during the creation of this demo, it is quite easy to create this infrastructure, deploy it easily. There are not too many things that we have to do. It helps us to scale and also provides us the flexibility depending on the workload. We can scale up or down. Being serverless, it definitely helps us to reduce the cost. And when we move to cloud, one of the biggest benefit is the cost reduction. People want to use the cloud in the most optimal way. We don't have to use the same traditional methods of sizing our infrastructure needs or the way we build applications. This also requires a slight change in the mindset. One of the typical questions that I get asked is, can I just lift and shift my application to cloud? And my answer typically is no. You need to change the mindset in the way you build the application. If you look at my example, my consumer is picking 50 messages in one chunk. If I don't do that kind of thing, I will not be able to scale the consumer. If the consumer picks all, let's say 10,000 messages, then there is no way I can scale it. So in order to use some of these features, the way we build application also, the mindset has to change, and we have to adapt to the best practices in which the cloud applications are built. And obviously there is no vendor lock-in here. We are using things which are like open source projects, and these can be deployed in a hybrid cloud environment or even in a multi-cloud environment. Things like Dapr and Keda, they work across clouds. So that really helps us to innovate and improve the customer experience. Some of
Nilesh,
the
if you wanna, I don't wanna maybe go too much details on on the microservice on this talk to not be too long, but
yeah,
maybe if you show one slide more to show all the use case that you can have on Azure Container Apps,
sure.
I think
Let's skip
maybe
this
we
part.
can.
Yeah,
I think you have one slide. Yeah, not this one, but if you go on the, let's compare. Yeah, that
what can
one.
we
I
build
think we could
using
finish
the
there
container apps? Yeah.
because we did
So
show one kind of use case that was event processing or
yes.
background processing. But do you wanna
So yeah,
show the
container apps,
possibilities there?
we can use it for almost any kind of workload that can run on uh, Azure. Not just Azure, it's basically microservices kind of applications. So we can build typical microservices which are like the backend processing services. At the bottom, we can also see what auto scale criteria can be used for this. So I will not go into each and every detail of this, but we looked at event processing or event driven processing. The typical web applications, the web APIs, they can be built and deployed on Azure Container Apps. We can have the public APIs. Again, things which we typically do with APIs like blue green deployment, then traffic splitting, canary releases, dark launches, all those kind of things, the advanced deployment techniques which are quite popular nowadays in terms of deploying the applications, cloud native applications. Those are all supported using Azure Container Apps. So we don't need anything separate. This comes out of the box, and that is a great enhancement for developer productivity, I would say. In some cases, you have to find some other product which can do this, but here we have Azure Container Apps, which has native support for all this, and also
And
the background processing.
yeah. And Nilesh, I would say I know that you have a slide, but the main point of Azure Container Apps is to be like a fully serverless. You don't have to maintain VMs. You don't have to maintain anything. You
Yes,
be that PowerShell. I'm going to share again your nice repository, like I said, if anyone wanna contribute and put a pull request there. You also have the five-factor authentication series there that you saw the slide. Let
yes,
me also share this playlist because it's amazing playlist Then you can go deep on the microservice side, how you can
Yes.
deploy, how can you build microservices with 15 factor apps and watching
Yes.
this playlist and try to deploy these on Azure Container Apps, fully serverless, fully managed by Microsoft. Um,
Yes.
I think if you want to compare, there is a documentation comparing the options, comparing AKS, Container Apps, and other Azure service that you can follow as well. Yeah, and your slide will be on the slide chat. I can see there already.
Yes. So the source
Um,
code and the slides, they are already published on the speaker deck, SlideShare, and the source code is on GitHub. So people can rebuild this whole demo. I have a series of docs as well within this repo, which shows how you can build this. If you want to create this same setup or similar setup, you can go to this repository, and in the docs, I have shown like step by step how do you build the application, how do you build Docker images, how you push them to container registry, how do you create the RabbitMQ cluster, how do you configure that cluster, and then how do we enable the container apps, because we need to enable this for our subscription, for Azure subscription. Then
yeah,
how to deploy. So we saw the deployment script here, and how to test and how to enable Keda. So all these things are documented in the projects repository, and you can recreate this whole setup and the demo yourself.
yeah, I think you're right. That's your next step. After watching this video, go try to do yourself. Go for the 15 factor apps and try to see how you can develop microservice if you're not doing that yet. Yeah, how to separate using message queue is a nice way to do microservice. Um, and I would just to finish ask for you to subscribe our channel. The Azure tar is a tarball, is a zip file for Azure. Yeah, subscribe the channel. Follow also all the community in Singapore that Nilesh, I have done the talk there recently. You can watch my talk. And we also, Nilesh, we have azuretar.com is a blog. You are also welcome to publish your blog there or republish. On this community, you have blogs in multiple languages. Then if
Okay.
you want to share code on the GitHub, we also have a GitHub account. And you have a Twitter and LinkedIn. The Twitter you can see here on my screen, the at Azuretar. And the LinkedIn, please subscribe and follow us on LinkedIn because I'm always publishing the news videos on LinkedIn. It's easier for you to get the notification. And Nilesh, thanks a lot. I think I can see your is it scaling down one
Yeah.
consumer.
So
Yep,
now the
it's always
consumers
scaling down.
came back down to one. So that was our scaling down demo, right?
Yep,
Since I had given the minimum replicas as one, it has scaled it down back to one. So I'm happy that we were able to demonstrate the scaling up and scaling down within
I know.
such a short period of time.
It is. It's amazing, and is a nice recap there. You deploy an environment with two container apps. You have a message queue and you put like thousands and thousands of message, and we have seen that a container app was able to scale quickly up and scaling down as well, and you just pay for the time that was running completely serverless. You could even scale to zero if you want, and don't pay
Yes,
anything. And what I really like is the possibility to leave you one instance running all the time and don't pay the full price. Just pay like a small fee for that standby instance, just to make sure that you have always one instance running, like a API, for example. I think that's a
yes,
nice one. And you don't have to wait for that to warm up because it's already running there.
yes. This is one more view which I personally like. If you go to the resource group, you see resource visualizer. It gives you a nice consolidated view of what you have in the group. So this is maybe a summary of what we did. We had the environment, the container instances or container apps environment. We deployed the producer consumer there. And then there was a RabbitMQ in the same resource group, but outside of our environment. And then along with this RabbitMQ, there are some the disk which is attached. There is the network interface. There is the public IP for RabbitMQ, and we also have the log analytics. So this view gives us the complete picture of what we used all together in the demo.
Sorry, that's nice, Nilesh. I think we could see the whole picture, and yeah, just give a go. Thanks a lot for take time to present for us, and I hope you come back with a segue or another subject. But yeah, if you want to come back to talk about 15 factor and improve your demo, go for the next level, put out
Yes.
observability, and bring more microservices would be nice.
Yeah, sure. Thank you. Thanks
And
for giving me this opportunity. I know it's a Saturday where we are recording this, and it's quite late for you. I really appreciate that, you giving us this some time to share our knowledge, and also appreciate you sharing your knowledge with the rest of the world. Thank you. Thanks, George.
yeah, thanks. And if you are watching this, you want to do the same as Nilesh, and you want to share something with us, even in another language, just let me know. Nilesh, if you want to record anything in another language there, also we are happy to publish on the channel. And yeah, see you on the next video. Thank you, everyone.
Thank you.